All right, folks, I will be doing AP 1.17 from the review on page 285. It is a chapter 3 overview. And what we're going to be doing is answering this question. So the first question is, describe the relationship between shelf life and sales. That is a look at the graph question. So I'm going to describe what I see. So you're describing the correlation from the graph. So the relationship between shelf length and sales. I'm saying three things. I want to mention direction, form, and strength. So we're going to say there is a strong, positive, linear relationship. You can say association if you want, or correlation. All of those are fine. Between, and then you're going to say the name of the explanatory variable first, which is shelf life, shelf length, and sales. Okay, so that's A. B, write the equation of the least square regression line. Be sure to define any variables you use. All right, so it's coming from the computer printout. Just a reminder, we're focusing on these two numbers. These are coefficients. This is either the y-intercept or the slope. The slope is the one that is describing the x, that is the coefficient of the x-intercept. So slope is going to be 152.68, and that's going to be the y-intercept. So what I'm going to do is I'm going to write the equation. Y hat is 152.68 times x plus 317.94. I am not done. What we do next is write down that y hat is predicted sales and x is shelf length in feet. So that's me defining the variables. Define variables. Very careful, guys. Do not skip. Super critical. Make sure everything you do in chapter 3 has context. It's always about something. All right, C. If the store manager were to decide to allocate 5 feet of space, what is the best estimate? I think we're being asked to use the equation that we just wrote down. So we're going to substitute in x is 5. And if I look at the graph, we have data from 3 to 6 feet, so this is fine. It's within range. So we're going to go with 152.68 times 5 plus 317. That's a lot of money. Okay. Good. So a 5-foot shelf is expected to generate about $1,000, right? Make this number easy to read, right? Of sales. All right. Interpret the value of S. All right, just a reminder, it's on the printout. It is here. This is your typical residual, your typical error. It's going to be in the units that your y-axis is in. So this is how far off the line is from actual values that you have. So this is a very, very small error. So just a reminder, we're doing S because the typical residual, the average of the residual is always 0 because that's how the line is made. So we're using the standard deviation of the residuals as a stand-in for the average, which we are not able to use because the average is always 0. So I'm going to say, on average, the least square regression line makes $22 errors estimating sales. Now, given how huge the sales values are, that is a tiny, tiny error. So I'm just going to say that. This line is really good at predicting. Right? Okay. E. Identify and interpret the coefficient of determination. I'm going to write this down. I feel like this is one of the vocab words that people forget the most. Coefficient determination is what percent of the variation in the y direction can be explained by changes in the x direction. This is r squared when you see this. So it's asking you to notice the r squared. It's just in the printout. It's 98.2%. And then you're supposed to interpret it. Tell us what it means. And what it means is that 98.2% of changes in sales, the y variable, can be, now you can use a variety of words here, predicted by, determined by, that's why the coefficient of determination, or explained by, all of those are fine. And then there's a variety of ways to finish the sentence too, by changes in x, or predicted by the line, predicting sales from shelf lengths. So I can finish the sentence a variety of ways, but 98.2% of changes in sales can be predicted by changes in shelf length. So we found by far the largest factor that is helping explain how much sales are being made. We're not missing a lot of variables here. This is a really strong one, right? And then lastly, we have the store manager saying, what am I doing with this y-intercept? So heads up, guys, shelf lengths go from 3 to 6 feet in our data set. Um, 0 feet is not in our range or even nearby. It's really far away, and if it's really far away, we're going to say extrapolation. We will not be selling $317 worth of personal grooming products if we have no shelf space in the store. Extrapolation means don't use the line, right? Because 0 is too far out of range. And the deal with that is that if you do assume that, you are assuming, which of course when you assume, you do fun things like making an ass out of you and me, assume the pattern continues far, right? You assume the pattern continues way off the page, which is probably not true. There we go.